So we're in section 13.1, probability, looking at two types of probability, theoretical probability and experimental probability. All right, and at the beginning of the lesson, we talked through a lot of different scenarios, but what it comes down to is theoretical probability is scenarios that I'm playing out. So the example that we gave was skydiving, all right? So if they tell you that there's a 1 in a million chance that your parachute does not open, then you can base your decision off of that, but you're not actually trying it a million times, okay? So theoretical probability is just that scenario, playing out scenarios. And then favorable, well, favorable is kind of a misleading word, just like I was talking about just a minute ago. It's basically the targeted outcomes. What am I trying to measure, okay? So if I'm trying to measure something, that's going to be what I put in my numerator, my favorable outcomes over the total. With experimental probability, it's actually carrying out the experiment. So we have number of successes. And again, successes is kind of misleading because it might be a bad outcome that I'm measuring. But again, it's whatever I'm trying to measure or what outcome I'm targeting or measuring, that goes in my numerator. All right, do you have them written down? Have them written down? All right, so now let's look at example 1. My example says that a bag contains 3 blue, 4 green, and 3 red marbles. Find the probability. Anytime I'm calculating probability, I prefer for your answer to be as a percentage. So if I'm finding the probability of blue, again, what you see in parentheses is my targeted outcome. That's what I call my favorable outcome. So how many blue marbles are there?
3.
There are 3 blue marbles out of how many total? 10. So that would be 30%. My probability of selecting a blue marble is 30%. All right, I want you to find probability now of red and green, and make sure you write your answer as a percentage. So what's the probability of red?
30%.
Same thing, 30%. What's the probability of green? 40%. Okay, 4 over 10, which is 40%. 40%. All right, now let's look at another probability scenario. Okay, here I'm rolling a number cube. Anybody play those board games that have the dice? Mm-hmm. Okay, so how many numbers are on a die?
Like 6.
6. No, 6. All right, on a typical number cube, there are 6 numbers. 1, 2, 3, 4, 5, and 6. So, based on that, find the probability that you would roll an even number. Well, out of those numbers, how many of them are even?
3.
Out of my total of 6, which is 50%. It's half. All right, so now I want you to find the probability that you roll a 4 and the probability that you roll a number less than 5. Okay, so what's the probability you land on a 4? What's the probability you land on a 4? 1 out of 6, which is what? 10%. No. What is it? 16%, perhaps?
How is it 1 out of 6?
Because it's 4.
Round right. It's actually supposed to be 17%. 17% because it's 1.6666. The 6 rounds the 6 up to a 7. 17%. All right, now how many are less than 5? 4, very good. 4 over 6, which is 67%. Again, you've got to make sure you round correctly. 0.6666, you round that 6 up to a 7. Okay? All right. So any questions on finding theoretical probability? So now let's shift gears over to experimental probability. The only real difference here, guys, is I'm actually carrying out the experiment. It's something that I can measure through trials. So a cat knows the shake command. offers, that knows the shake command, offers either of its front paws. Find the probability that the cat will offer its right paw. All right, so I use the table here, right and left paw, to calculate this experimental probability. And again, it's number of successes over trials. What does successes mean? It just means the targeted outcome. What am I trying to solve for? All right, so go ahead and try to write that probability. Okay, so how many times did he offer his right paw?
12.
Only 12. Okay, so he offered the right paw 12 times out of how many? 50. So what's my percentage?
24%.
All right. Now, before I even calculate left, does anybody know a way to figure out the percentage?
Yes.
What? If he offered his right paw 24% of the time, subtract it from 100, because it's one or the other. He either offers his right or his left. So if he offers his right 24% of the time, then his left would be offered 76% of the time. It's got to add up to 100. Now, if I was calculating the fraction, though, 38 over 50 is 76%. 76%. All right, experimental probability. Any questions?
No, ma'am.
All right, one more slide. Of the 20 voters after an election, so they're present, you can ask each one of them individually, so that's why this is experimental. What is the probability out of the 20 voters that they voted for Sean? If 14 of them voted for Sean, what's the probability that you walk up to someone and they actually did vote for him? So calculate this experimental probability. Again, what am I seeking for? What is my targeted outcome here? The probability of what? That they voted for Sean. Okay? Voted, and we can kind of abbreviate it, voted for Sean. Probability of Sean, voted for Sean. All right, and how many people voted for Sean? 14 over 20, which is what as a percentage? 70%. So there's a 70% chance if I walk up to a random person that they actually voted for Sean. All right, any questions?
I thought there were 20 voters that voted for some guy.
No. All right, so if you understand that, that's everything you need to know for 13.1.
That's all we need to know.